In this concept, we're going to talk about trapezoids and kites. A trapezoid is a quadrilateral with only one pair of parallel sides. So while a parallelogram had two pairs of parallel sides, right? So parallel, 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 parallel. A trapezoid only needs to have one pair of parallel sides. These do not have to be parallel. Okay. Now, if the two legs of a trapezoid, which are these guys, are congruent, so you start off with two parallel sides, you get a trapezoid. If you have congruent legs, then the trapezoid is called an isosceles trapezoid. Let's look at this example. So we have trapezoid ABDC, and in it we have obviously these two. So AB is parallel to CD. In an isosceles trapezoid, each pair of base angles are congruent. So first off, we're being told that AC is congruent to BD. So this leg is congruent to this leg. So this gives rise to a set of interesting features. Each pair of base angles is congruent, right? So in the figure above, angle CAB is congruent to angle angle ABD. So angle CAB, which is this angle, right, is congruent to this angle. And then angle ACD, which is this angle, is congruent to this angle, angle BDC, since the trapezoid is isosceles. We have another feature of trapezoids, and that is the midsegment. So a trapezoid midsegment connects the two midpoints of the legs of a trapezoid. Okay, so legs AC and leg BD each have midsegments. AC has a midpoint. Midpoint of leg AC is point E. Midpoint of leg BD is point F. Midpoints. Okay. So the midsegment is the line that connects the midpoints. And what are the features of this line, the midsegment? Well, first off, it's parallel to both bases, the lower base and the upper base. Okay. AB and CD in this case. The other feature of this segment is that it is equal to the arithmetic mean of the length of the bases, meaning you take the length of base 1 plus the length of base 2, let's say LB1 and LB2, right? And then divide it by 2. And that is the length of your midsegment. Okay? Let's look at this example. Find the length of EF, which is our midsegment. Well, we're given the lengths of the two bases, 12 and 25, right? So we add them together and we divide by 2, essentially finding the arithmetic mean of the lengths of both bases, which gives us 37 over 2, which gives us 18.5 units. And this is the length of the midsegment. Okay. Now let's look at kites. So a kite has the following basic structure. Well, it looks like a kite. Okay. Some properties of kites are that, so they basically have two pairs of congruent consecutive sides. So consecutive sides are congruent, and there's two pairs of them, right? Let's say we had one pair of congruent consecutive sides, but then the other were not congruent, right? Let's say it looks like this. then this is not a kite. These two are congruent, these two are not congruent. So this is not a kite. Okay? Gotta have two pairs. One pair, second pair. Congruent. Then it's a kite. Another interesting property of kites is that they have perpendicular diagonals. So if you drop the diagonals, they are perpendicular to each other. Okay, and here we have our exercises. Please pause the video, work on these, and come back for the solutions. Okay, we need to determine whether the following statements are true or false. The legs of an isosceles trapezoid are congruent. And this is actually true for it to be considered an isosceles trapezoid. The second statement, the diagonals of a kite are congruent. This is actually false. Why is it false? Well, because you could just draw the kite, right? And then here are the diagonals. I mean, you can clearly see one is always longer than the other, so they cannot be congruent. They are, however, perpendicular. So the diagonals of a kite are perpendicular. So this is actually true. As we mentioned, right? They are perpendicular. The midsegment of a trapezoid measures half the measure of the larger base. And this is actually false. It is not half the measure of the larger base. It is equal to the arithmetic mean of the sum of lengths of both bases. So again, it is equal to, so the length of the midsegment is equal to the length, this is an L by the way, yeah, it's an L, is equal to the length of base 1 plus the length of base 2 over 2. Okay, that's what it's equal to. Okay, next we need to find the length of the midsegment of the following trapezoid. So we have this trapezoid, ABDC, and we have both bases with given lengths, 40 and 85. So the length of our midsegment is equal to the length of base 1 plus the length of base 2 over 2, which is 40 plus 85 over 2, which is 125 over 2, which is 62.5 units. Okay? Alright, and this is it for this concept. See you in the next video.